There is a paradox in our time. We can see galaxies whose light has traveled billions of years to reach us, but we struggle to see the wounds in one another's hearts. We map the structure of the cosmos in exquisite detail, even measure the whispers of dark matter, but we often miss the silent signals right here on Earth. We probe the origins of time, yet the brevity of our lives still amazes us. Tonight, I want to tell you about a galaxy that shouldn't exist, not by our current models, not by our textbook expectations, but one that stubbornly refuses to disappear. A galaxy that defies the death clocks we set for cosmic structures. Its existence is an anomaly. Its perseverance is a challenge. Why should it matter to you? Because the cosmos is not a distant museum. The universe's anomalies are not oddities at the margins. They are messages, invitations. Look deeper. Reconsider your assumptions. Reconnect your sense of possibility. So let us begin not with certainty, but with curiosity. Galaxies are born, live, and die in cosmic time. They start small, accrete mass, form stars, collide, shed gas, and eventually, under certain conditions, fade. They become quiescent. Their star formation slows to a crawl. Their gas reservoirs exhaust, and they turn red, passive, inert. They are the cosmic equivalent of elderly cities, whose walls crumble and whose lights dim. Our theoretical framework suggests that many galaxies by now should be dead, no new stars, no new light, no vibrant activity. Yet we observe some that still blaze, still spin with vigor, still surprise us. One of them is the galaxy that should have been dead billions of years ago. It is a testament to complexity, chance, and cosmic resilience. To understand why its survival is surprising and why its story matters to our story, we must walk through the physics of galaxies, from gravity and dark matter to feedback processes, gas accretion, star formation, and cosmic environment. Let's start with how galaxies grow. When the universe was young, matter was more evenly distributed. Tiny fluctuations in density grew by gravitational attraction. Dark matter, invisible but dominant, formed scaffolding, halos of potential wells. Baryonic gas fell into those wells, cooled, condensed, collapsed. Stars ignited. Over time, galaxies grew by merging and gas accretion. But that process is not infinitely sustaining. Galaxies run out of fuel. Their gas becomes heated, expelled, or locked away. Powerful feedback from supernovae and active galactic nuclei, AGNs, can blow gas outwards. The galaxy's gravitational pull may weaken in outer regions. The cosmic supply of fresh cold gas may diminish. Over time, a galaxy can transition from the blue cloud, star forming, into the red sequence, quiescent. Given the age of the universe, about 13.8 billion years, many galaxies of a certain mass and environment would by now have exhausted their star-forming potential. Many should be dead. Yet, astronomers have found galaxies whose properties suggest they should be quiescent, but are not. The one I want to call your attention to is one of the more extreme cases. Observations show that it still forms stars at a significant rate. It retains cold gas reservoirs. It shows spectral lines of hydrogen and oxygen emissions that signal youth, not dormancy. How is that possible? To answer, we must dig into the mechanisms that suppress or sustain star formation. Let me highlight a few. Gas accretion from the cosmic web. The universe is not static. Filaments of cold gas can funnel matter into galaxies. If a galaxy remains connected to these streams, it can continue to replenish its fuel. Even when internal processes try to shut it down, the external supply can keep it alive. Cooling and heating balance. Hot gas in galactic halos may try to prevent cooling, creating a hot mode that suppresses condensation. But if some mechanism allows gas to cool, perhaps via instabilities, mixing, or turbulence, then star formation can continue. Feedback regulation. AGNs and supernovae can heat or eject gas. But if regulation is gentle, if feedback is just enough to prevent catastrophic collapse, but not so much as to expel all fuel, then a galaxy may hover in a semi-active state. Galaxy environment and interactions. A galaxy in a denser environment, or in a group, may receive gas or interactions that rejuvenate it. Tidal interactions and minor mergers can stir gas, cause inflow, or reignite star formation. This galaxy, let's call it Perseverantia for now, seems to solve a delicate balance. It resists death by maintaining gas inflow, moderating feedback, and preserving conditions for cooling and star formation despite cosmic aging. But there is more. Observations also suggest structural anomalies, a dense central region, unusual metallicity gradients, perhaps even intermittent AGN activity, not strong enough to quench, but enough to modulate. Those features tell us that the galaxy's survival is not serene. It is a constant negotiation between competing forces. Let me pause the astrophysics for a moment to speak of what this means for us. Why does the existence of Perseverantia matter to our human story? Because it teaches us that longevity, even in cosmic systems, is not about inertia. It's not about existing by default. It's about resilience, adaptation, balance, and agency. Consider civilizations. They may rise, plateau, and decline unless they adapt. It's not external forces alone, climate, war, resource depletion, that determine longevity. It's the internal capacity for feedback, renewal, humility, and connection. The same principles that allow a galaxy to persist, supply, regulation, exchange, also apply to human societies. This galaxy that should be dead but isn't asks of us, what processes do we maintain to stay alive as a civilization? How do we manage feedback? How do we remain connected to our sources? How do we cool ourselves when we overhear back to the stars? Now, how do we measure that Perseverantia is indeed still active? Astronomers use multiple probes, spectroscopy. The light emitted by ionized gas Alpha, O392 solines, reveals star formation rates, gas density, temperature, metallicity. In Perseverantia, these emission lines are strong, standing out against the continuum, contrary to what one expects in a quiescent galaxy. Infrared observations. Young stars heat dust, which re-radiates in the infrared. If a galaxy shows an infrared excess, it implies recent or ongoing star formation. Neutral hydrogen mapping. Cold hydrogen gas is the raw fuel for star formation. If HI reservoirs exist and can be mapped, they show that the galaxy has fuel to burn, even if modest. Morphology and color gradients. The galaxy's color bluer in outer arms, perhaps redder core, and stellar population gradients can suggest where new stars are forming and where old stars dominate. AGN diagnostics. If there is a weak AGN, it might show narrow emission lines or radio signatures that do not completely shut down the galaxy, but modulate conditions. When multiple indicators converge, we conclude that this galaxy is not a relic of the past, but a beacon resisting cosmic senescence. Galactic survival over billions of years is a high-wire act. It requires that the cooling timescales, gas inflow rates, feedback efficiencies, and cosmic environment be tuned just so. Slight deviation in any parameter might push the galaxy into a quiescent state. And yet, Perseverantia, again, provisional name, tips the balance just enough to keep shining. When we model its evolution forward, projecting 1-2 billion years, many models show an eventual decline. Gas inflow weakens, feedback gradually dominates, star formation fades, cold gas is consumed or heated. But we are here at an epoch where we can see it still defy that fate. What does that tell us about cosmic time? It reminds us that time is not always a straight fade. It is a tapestry of possibility. Structures we expect to wither may persist. Systems we expect to collapse may reorganize. The universe tolerates exceptions. The cosmos is not a deterministic clock, but a dynamic landscape of probabilities. Let me return to you, the listener. When you gaze at the night sky, when your telescope or your heart reaches out, don't see galaxies as static, monolithic objects. See them as stories in motion, as conversations across time, as systems balancing forces, as participants in cosmic ecology. We often think of progress as forward motion, linear ascent. But sometimes the grandest challenge is to resist decay, to persist, to adapt, to regenerate. Civilization is not assured. Life is not assured. Even stars, galaxies, planets, these too, must contend with entropy, resource depletion, exhaustion. We are not separate from these cosmic processes. We are part of them. Our world, our biosphere, our technologies, our societies, they breathe, evolve, strain, falter, renew. In the centuries ahead, we will learn more about perseverantia, or its real name, or others like it. We will map gas filaments, measure inflow velocities, simulate feedback cycles, compare populations across cosmic time. We will refine our models, adjust our assumptions, perhaps rewrite what we believe a galaxy's life expectancy to be. But the deeper lesson lingers. When the universe gives you a galaxy that shouldn't exist, pay attention, because it tells you that survival, even in the most unlikely circumstances, is possible. That resilience is built upon flow, connection, regulation, and humility in the face of forces beyond dominion. Tonight, as you walk under the stars, think of perseverantia, a galaxy that refutes the hand we thought time dealt. Think of your life, your communities. Do we have the flows we need? Are we receiving renewal? Are our feedbacks gentle or destructive? Are we overextending ourselves or sustaining just enough tension to stay vibrant? Because the cosmos is not a passive backdrop. It is a mirror and a teacher. It shows us what is possible not just in stellar systems, but in human systems. When astronomers first pointed their instruments toward this region of sky, they weren't looking for a miracle. They were taking a census. In the late 20th century and early 21st, we built machines that could photograph millions of galaxies at once, giant digital eyes, like the Sloan Digital Sky Survey, the Hubble Space Telescope, and later, the James Webb. These telescopes turned the night sky from a mystery into a database. Each point of light became a line on a graph. Brightness versus wavelength, the telltale redshift that tells us how far and how fast something moves. From those spectra, astronomers could reconstruct a galaxy's biography, the age of its stars, the temperature of its gas, the metals forged in supernovae, the rate at which it still gives birth to light. And that's when someone noticed an outlier, a system whose light should have long since faded to crimson, yet pulsed with the blue signature of newborn stars. At first, the data looked wrong. The redshift placed the galaxy at an epoch when it should already have been quiet, roughly 11 billion years after the Big Bang. By then, most galaxies of its mass were retired giants, content to glow faintly with ancient stars. But this one radiated the fingerprints of hydrogen recombination lines, clear evidence of current star formation. It was as if someone found a living, breathing tree in a petrified forest. Of course, science begins in skepticism. Was the observation contaminated? Was there a foreground object, a younger, closer galaxy aligned by chance with an older, dead one? For months, researchers compared photometry, checked for gravitational lensing, analyzed dust absorption. But the anomaly held. This galaxy, against probability, was alive. It earned the nickname Phoenix not because it rose from ashes, but because it never stopped burning. To appreciate how strange that was, you need to know how galaxies age. A young galaxy is like a bustling city. Gas flows in from intergalactic space, collapses into stars, and those stars die in fireworks that recycle elements back into the mix. But the same fireworks also create winds that blow gas away. Over time, the city runs out of raw material. Without gas, no new stars form. The lights go out. Massive galaxies die first. Their own gravity fuels supermassive black holes whose radiation heats the remaining gas so much that it can no longer cool and condense. By the age we observe Phoenix, that fate should have been sealed. And yet, its spectroscopic fingerprints told another story. Cold gas, high metallicity, and a stellar population far too young for its age. It forced astronomers to reopen questions they thought were settled. Could the cosmic web still feed old galaxies with fresh gas streams? Could interactions with invisible satellites reignite star formation? Could internal feedback thought to quench life instead sustain it in cycles? Every answer generated more questions. And that's how science grows, not in comfort, but in discomfort. What fascinates me is that this moment, this realization that the universe had surprised us again, mirrors a pattern as old as humanity itself. Every epoch of discovery begins with something that doesn't fit. In the 1500s, it was planets that wandered in ways Ptolemy couldn't predict. In the 1800s, it was spectra that revealed elements unseen on Earth. In the 1900s, it was galaxies retreating from us, expanding the very fabric of space. And now, in the 2000s, it is galaxies refusing to die on schedule. Each time, nature looks us in the eye and says, "You don't know me as well as you think you do." That is both humbling and liberating, because if reality can surprise us on scales of billions of years and trillions of stars, then hope itself becomes a scientific principle. The universe allows for more possibilities than we have yet imagined. The study of Phoenix and its kin led to a renaissance in galaxy evolution theory. Astronomers began to catalog rejuvenated galaxies, objects that had once been quiescent but somehow reignited. Some showed evidence of mergers, others of fresh gas accretion, still others of subtle magnetic or gravitational effects that kept turbulence alive just enough to keep the lights on. But no single mechanism explained them all. The lesson was clear. Longevity, even on a cosmic scale, is plural. There is no one recipe for survival. There are only systems that find ways to keep exchanging energy and information with their surroundings. That realization is not limited to astrophysics. You can read it as a metaphor for any complex system, ecologies, economies, civilizations, even individual lives. When a system stops exchanging, stops adapting, it fades. When it stays open, accepting feedback, sharing resources, balancing input and output, it persists. By the time the James Webb Space Telescope joined the story, its infrared vision pushed our view farther and earlier. Webb's detectors pierced through the dust and confirmed what earlier telescopes hinted. Galaxies much older than expected were still forming stars at vigorous rates. The models had to bend to the data. Maybe the universe was more efficient at recycling than we thought. Maybe death, in cosmic terms, is less of an end and more of a phase. And that, to me, is a profoundly philosophical idea, because it suggests that the universe is not a linear narrative, but a dialogue between collapse and renewal. Stars die to seed new ones. Galaxies fade to feed others. Entropy increases, but structure reemerges in new forms. Life, consciousness, culture, they all echo that same rhythm. The discovery of the impossible galaxy didn't just extend our map of the cosmos. It extended our map of meaning. It reminded us that the limits we perceive of age, of energy, of possibility, are often projections of our own impatience. The universe operates on timescales where rebirth is as natural as decay. And if we listen closely, that rhythm is telling us something about ourselves. That endurance is not defiance of physics, but partnership with it. When you look closely at a galaxy, what you're really seeing is an argument between gravity and energy. Gravity wants to pull everything inward, to concentrate matter into a single point. Energy, thermal, radiative, magnetic pushes outward, trying to spread that matter apart. Between those two impulses lies existence. For a galaxy to live, it has to keep that conversation balanced. Too much gravity, and it collapses into darkness. Too much energy, and it blows itself apart. Survival is the art of staying in tension long enough for creation to happen. It's the same dance that defines stars, ecosystems, and civilizations. Too rigid, and nothing new can form. Too chaotic, and nothing lasts. Everything that endures lives on that narrow edge where order meets flow. So what precisely keeps a galaxy like Phoenix alive? Start with the fuel. Star formation depends on cold molecular gas, hydrogen, and helium that have managed to cool enough to collapse. Cooling isn't easy. It requires radiation to carry energy away. Metal atoms, oxygen, carbon, iron act as the coolants, radiating in the infrared and allowing clouds to condense. Without those trace elements, there is no chemistry, no stars, no life. Now, consider feedback. Each generation of stars injects energy back into the gas through winds, ultraviolet radiation, and supernovae. Too much feedback, and the gas heats, expands, and escapes. Too little, and gravity wins, triggering a burst so intense that it consumes all the available fuel. The galaxy burns out. Phoenix survives because it regulates its feedback like a heartbeat, steady enough to keep circulation, gentle enough not to rupture the system. Its supermassive black hole pulses weakly at the center, releasing jets just powerful enough to stir the surrounding medium to prevent catastrophic cooling, but not strong enough to evacuate the gas. It's a cosmic thermostat, oscillating around equilibrium. In that sense, the galaxy behaves less like a machine and more like an organism. It breathes, gas in, stars out, collapse, expansion, recovery, and ecology, not an engine. When you think of it that way, you realize how much of physics is really about sustainability. Every stable structure, from an atom to a galaxy, exists because competing forces learn to coexist. The equations of motion are, in essence, peace treaties. The laws of thermodynamics are ethics written in energy. And we, too, live by those laws. Our bodies regulate temperature, chemical potential, and entropy the same way a galaxy regulates pressure, gravity, and radiation. Our societies regulate information and resources. Too much centralization and they implode, too much chaos and they disperse. The physics of staying alive scales from the cell to the civilization to the cosmos. When I first learned that Phoenix was still forming stars billions of years past its supposed expiration date, I thought about how easily we declare things finished. We speak of the end of eras, relationships, even hope as if decay were destiny. But the universe seems to prefer cycles to endings. Entropy increases, yes, but structure re-emerges at new scales. Order doesn't vanish, it migrates. Look at the periodic table. Every element heavier than helium was born in a star that exploded. Every atom in your blood once rode the shockwave of a supernova. Destruction in the cosmic lexicon is simply redistribution. Phoenix is proof that even in exhaustion, there can be renewal. Let's step back for a moment. Why should a patch of light, millions of light years away, matter to us? Because it demonstrates that survival is not a miracle, it's physics properly understood. If the right feedback loops exist, if energy and matter continue to exchange information, if systems stay open to their environment, life of some kind continues. The same lesson applies to the biosphere beneath our feet. Earth's ecosystems are a kind of living galaxy, powered by sunlight instead of gravity. Carbon cycles, water cycles, nutrient flows, all are feedback loops balancing input and output. When we overload those loops, when we inject more energy than the system can radiate, imbalance follows. Climate shifts, biodiversity collapses, stability vanishes. We are, in effect, testing whether we can run a planet the way the universe runs a galaxy, in dynamic equilibrium. So far, the results are inconclusive. The beautiful irony is that we already know the principles. Nature demonstrates them everywhere. Stability through exchange, not isolation. Resilience through variability, not rigidity. Renewal through feedback, not denial. These are as true for galactic disks as for democracies. When we ignore them, systems decay. When we honor them, systems thrive. Phoenix, the galaxy that shouldn't exist, endures because it learned how to listen to its own feedback. It doesn't silence the energy that threatens to unmake it. It uses that energy to sustain itself. Imagine if we did the same. The next time you hear the phrase heat death of the universe, remember that between the equations lies improvisation. Even as entropy climbs, islands of order continue to form, evolve, and adapt. Galaxies like Phoenix are those improvisations, fluctuations of resilience in a sea trending towards stillness. Perhaps the universe isn't just running down. Perhaps it's learning how to linger. We look at a galaxy that has learned to live in balance and we call it an anomaly. But maybe it isn't the galaxy that's strange. Maybe it's our definition of life that's too narrow. When I study something like Phoenix, what I really see is a mirror. A reminder that survival is not about resisting change, it's about shaping it. Galaxies, ecosystems, and societies all face the same question. How do you keep complexity alive in a universe that trends towards simplicity? The answer, everywhere, is feedback. When a forest grows too dense, fire returns nutrients to the soil. When an economy overheats, cycles of correction restore stability. When a star explodes, it seeds new stars. Destruction isn't the enemy of life, it's one of its instruments. The universe is not cruel, it's efficient. The tragedy comes when consciousness, that rare privilege of awareness, refuses to learn from the pattern. We are the first species on Earth to understand feedback and the first to ignore it at scale. We burn fuel faster than the planet can radiate the heat away. We extract resources faster than ecosystems can renew them. We hoard information faster than wisdom can filter it. In physics, that's called a runaway reaction. In human terms, it's hubris. Yet the very same brain that created the imbalance can restore it? Think about that. The Milky Way doesn't know that it exists. Phoenix doesn't celebrate its improbable life. But we can. We can choose to act in ways that preserve the delicate tension between gravity and light, between consumption and renewal. That's what responsibility means when you see yourself as part of the cosmos. To understand that the laws of energy apply to ethics too. Our history has its own feedback loops. Empires rise by concentrating power, then fall when the pressure can no longer be contained. Societies flourish when they circulate knowledge and opportunity, and decay when those flows stagnate. Every civilization is a kind of star system bright for a while, then dimming unless it finds a way to recycle its energy into something new. We are at a turning point a few generations into the Anthropocene. We can continue extracting, heating, and hoarding until the atmosphere and the oceans remind us that equilibrium isn't optional, or we can learn the lesson that Phoenix has written in light across the universe. Stability through renewal, not through stasis. Imagine if we treated our planet the way the cosmos treats its galaxies, allowing feedback, embracing diversity of energy sources, building systems that adapt rather than resist. Imagine economies that circulate resources instead of consuming them, technologies that amplify awareness rather than addiction, and education that ignites curiosity instead of conformity. That is not utopian, it's thermodynamic. It's the only way a complex system survives. The beauty of seeing humanity through the lens of astrophysics is that it gives scale to humility. We realize that we're small, yes, but not insignificant, because awareness, even in one small species, changes the equation. The universe without consciousness is a symphony without a listener. With us, it becomes aware of its own music, and maybe that's our role, to be the feedback of the cosmos, to take in energy, meaning, and experience and radiate understanding back, to turn raw existence into insight and insight into compassion. When I think of the galaxy that should have died but didn't, I imagine it whispering across the void. Stay open, keep moving, balance your fires. That is the physics of hope. Not blind optimism, but the measurable possibility that systems can learn. So when people ask me if humanity has a future, I tell them, look at Phoenix. If a billion suns can keep finding new fuel after billions of years, so can we. There's a moment in every age of discovery when curiosity collides with conscience. We build tools that let us see farther, but those same tools make us see ourselves. When Apollo 8 first orbited the moon, humanity looked back and saw a blue sphere floating in blackness. That image, Earthrise, did more for environmental awareness than any law ever could, because it showed in a single frame what we truly are: one world, one atmosphere, one story. Now, telescopes like Webb are giving us a new Earthrise, only this time it's cosmic. They're showing us galaxies that refuse to die, worlds forming in dust, the chemical signatures of life's ingredients scattered everywhere. They remind us that creation is common, but awareness is rare. And if awareness is rare, it carries obligation. We are the universe's chance to care about itself. That's not poetry, it's physics meeting empathy. The energy that once fused in stars now thinks, feels, and decides through us. Every decision we make, how we use power, how we treat one another, how we explore, feeds back into the same equations that govern stars and galaxies. When you burn a fossil fuel, you change the atmosphere that protects you. When you launch a probe into space, you change the reach of consciousness. Both acts ripple outward, both are cosmic. Responsibility in this context isn't a burden, it's participation in the grand feedback loop of the universe. There's another paradox worth considering. We are the most fragile thing the cosmos has produced, and yet we're the only thing capable of protecting it. Planets don't save themselves, civilizations do. And civilizations don't endure through conquest, they endure through cooperation. If the galaxy Phoenix could talk, it might tell us that survival demands permeability, a willingness to exchange energy and information with the environment instead of hoarding it. For us, that means curiosity without greed, progress without blindness, exploration without exploitation. Think about how we approach space now. We talk about colonizing Mars, mining asteroids, extracting resources, but perhaps the next phase of exploration should be less about taking and more about listening to the data, to the physics, to the lessons already written in the stars. Every planet, every system we study adds another verse to the cosmic story of balance. Our role is to read it well. When I speak to students, they often ask, what can one person do against problems that big? And I tell them, physics begins with small perturbations. A single fluctuation in the early universe seeded the galaxies we see today. A whisper of imbalance led to everything. So never underestimate a single act of awareness. In systems theory, feedback begins with a signal. Be that signal, whether it's a new idea, a compassionate gesture, or a scientific question, it alters the trajectory of entropy, if only slightly, toward understanding. Because entropy is inevitable, but ignorance is optional. Imagine if we approached our century's challenges the way astronomers approach Phoenix. With humility, with curiosity, with the assumption that anomalies are teachers, not threats. Climate change, inequality, technological displacement. These are our cosmic anomalies. They are the phenomena that tell us where our models of civilization are incomplete. If we respond with fear, we stagnate. If we respond with study, we evolve. That's what the universe keeps showing us. Adaptation is not a sign of weakness. It's the signature of intelligence. The galaxy that should have been dead billions of years ago isn't lucky, it's smart in the thermodynamic sense. It learned to regulate, to distribute energy, to renew. We can too. And here's the part I love most. Responsibility doesn't shrink wonder, it expands it. When you act as a caretaker of something vast, you feel more connected, not less. Stewardship is how love looks when scaled to a planet or to a cosmos. So let's reimagine what progress means. Not speed, but sustainability. Not dominance, but harmony. Not extraction, but exchange. Because one day, when the last light from our sun fades and some distant civilization studies our galaxy, I want them to find evidence, not just of intelligence, but of kindness. I want them to see that for a brief moment, the universe knew it was alive and acted accordingly. There's a truth hidden in every beam of starlight. Nothing luminous lasts, but nothing luminous is ever wasted. The photons streaming from a galaxy like Phoenix began their journey before Earth had oceans, before the atoms in your body had found each other. They have crossed billions of years of emptiness only to end their story in the back of your eye. In that instant, the universe completes a sentence it started long before you were born. That is what awareness does. It closes loops. It turns energy into meaning. It transforms distance into connection. When I think of that, I stop worrying about immortality. I start thinking about continuity, because immortality is impossible, But continuity is guaranteed every time something we do or build or love outlives our own heartbeat. A good idea, a child taught to wonder, a planet kept habitable, these are forms of light too. Maybe that's what the cosmos asks of us. Not permanence, but participation. To burn cleanly, to give more light than smoke, to add one clear note to the endless chord of creation. The stars will fade, the galaxies will drift apart. But somewhere, deep in the data of the universe, the fact that we noticed, that we cared, will remain. Awareness leaves a trace. So tonight, when you step outside and see the faint haze of the Milky Way, remember that you're looking at a story still being written. Remember that even galaxies deemed impossible continue to shine. And remember that within you, the small, bright core of consciousness, the same law holds true. You are the universe learning to keep its own fire alive. You are the light that outlives you. And that's where the paradox dissolves into a vow. Because the more precisely we measure the universe, the more precisely the universe measures us. It calibrates our courage. It tests our capacity to learn in public. It asks whether the species that can see a galaxy refusing to die will choose to refuse despair. There is a discipline to wonder. It's not just the goosebumps at first contact with the unknown. It's the daily practice of earning your awe. Scientists know this rhythm. Hypothesize, test, fail, refine, repeat. It's not glamorous. It's a long conversation with reality where the universe speaks softly and only after you've done your homework. But when it answers, when a spectrum splits the dark with a line you didn't expect, it rewrites more than your paper. It rewrites your posture toward possibility. So let's practice that posture in our shared life. Imagine public conversations that treat anomalies as invitations, not enemies. Imagine schools that teach uncertainty as a muscle, not a flaw. Imagine leadership that understands feedback as oxygen, not threat. The cosmos is telling us patiently, persistently, that staying alive at scale requires permeability. The membranes of every thriving system are selective, not sealed. The living cell exchanges. So does the living mind. So does the living civilization. Now, it's easy to romanticize a galaxy and forget the math. But the math is the romance. Behind every image that stirs your heart stands a calculus that earned it. Phoenix Perseverantia doesn't believe its way to survival. It arranges flows, times its losses, budgets its heat. If you want a parable for a century as complex as ours, take that one. Budget your heat. Spend your outrage like fuel for clarity, not combustion. Route your attention the way a wise galaxy routes its gas toward star-making, not flares that burn bright and leave nothing behind. You might ask, is there a limit to this analogy? Of course. We are not galaxies. We can choose. That is our one physical superpower in a universe otherwise content to follow gradients. Choice. We can decide to align behavior with the physics that sustains complexity. We can decide to correct in time. We can decide here and now that progress is not a speed, but a stability, an arrangement of flows that lets more minds wake up, learn, and contribute before the light goes out. So let's be specific, because the cosmos always is. What are our inflows? Curiosity, education, culture, biodiversity, trust. What are our outflows? Waste heat, pollution, misinformation, cynicism. What are our thermostats? Science, journalism, the arts, the rule of law. The empathy that stops a feedback loop from running away. What are our mergers? Collaborations across disciplines, borders, and generations. What is our quenching? Dogma so rigid, it shuts the valves that would have saved us. What is our rejuvenation? A community that welcomes a better idea even when it threatens yesterday's status. In this light, responsibility is just thermodynamics with ethics. If you accumulate power, radiate it as opportunity. If you gather knowledge, re-radiate it as understanding. If you receive grace time, health, luck converted into light someone else can use to see. You will not beat entropy by pretending it isn't there. You will outlast it locally and temporarily, by turning your life into a conduit where energy passes through and leaves meaning behind. And yes, there will be nights when the sky feels empty and your instrument fails. There will be proposals rejected, relationships strained, models that collapse in the shadow of a single stubborn datum. Hold fast. The history of knowing is a sawtooth curve, sudden drops followed by plateaus of deeper coherence. The universe is patient. Be patient with yourself as a participant in it. Because here's the secret baked into starlight. The cosmos doesn't require perfection to make beauty at scale. It requires persistence under correction. Stars blow off mass. Galaxies shear their arms. Planets migrate. Moons tug. Still, the music holds. Still, the structure emerges. Still, from turbulence, a shape. You do not need to live a flawless life to live an astrophysically admirable one. You need to keep your flows honest, your feedback audible, your humility within reach of your ambition. One day, if we are wise, our descendants will point instruments back toward us and read our spectrum the way we read Phoenix today. What will they see in our light? A planet running hot with anger and extraction? Or a world that learned to tune its emissions? Will they find a civilization that flared and faded? Or one that mastered the heartbeat of renewal? I hope they find the latter. I hope they see in our signatures a turn faint at first, then decisive, where we chose to match our appetite with our atmosphere, our power with our prudence, our genius with our gentleness. I hope they catch the echo of classrooms that treated questions like kindling and laboratories that treated failure like a compass, of neighborhoods that measured wealth and trust, of leaders who understood that the most advanced technology on Earth is cooperation at scale. And if they do, it will be because enough of us decided to live like astronomers of our own behavior, measuring, sharing, correcting, and trying again. It will be because we learned to love the world with the same rigor we bring to loving the sky. So when you step outside and the Milky Way leans over your street like an old friend, let it coach you in the simple disciplines that keep fires clean. Breathe before you speak, verify before you share, repair before you replace, listen before you lead, seed more than you spend. Keep your orbit wide enough to learn from others and tight enough to stay committed. Let your core be dense with purpose and your edges friendly to new light. Somewhere, at this very moment, a photon that left Perseverantia before language existed is landing on the back of someone's eye. It crosses the last millimeter of its billion-year journey and becomes a thought. Maybe that someone is you. Maybe this is the night you decide to become a better radiator of what the universe entrusted you. Attention, compassion, courage. You promised at the beginning to start not with certainty, but with curiosity. Keep that promise. Certainty is brittle. Curiosity bends. And bending is how you survive tides of change. Bend toward each other. Bend toward the evidence. Bend toward the possibility that what shouldn't exist can, if you balance your fires and keep your channels open, and if you need a final instruction from a galaxy with a stubborn heartbeat, take this one. Don't aim to be eternal. Aim to be continuous. Leave behind a spectrum someone can read and say, here was a life that learned the art of staying lit without burning out. Here was a species that learned, finally, to harmonize its gravity with its light. That's our paradox resolved. The farther we see, the closer we must care. The more galaxies we count, the more wounds we can heal. The universe has shown us the choreography. Now it's our turn to dance steady, balanced, radiant, until our brief brightness has taught the darkness something new. So, as we reach the end of this journey from the birth of galaxies to the flicker of human conscience, remember this. The story was never about the stars alone. It was about what their persistence teaches us about our own. Every beam of light that reaches your eyes tonight began as an act of defiance against darkness. Every photon is a survivor of unimaginable odds. And yet, it does not boast, it does not hoard, it simply travels, gives itself freely, and in doing so becomes meaning. That is our inheritance. To carry the fire forward not in arrogance, but in gratitude. to live as if awareness itself is a sacred trust lent to us by a cosmos that has waited billions of years to think through our minds. You don't need to conquer the universe. You just need to keep its rhythm alive in your own heart. Collapse, release, renew. Lose nothing of your wonder, even when the world seems dim. Because wonder is the most renewable resource in the universe. And when your time comes, when your own light begins to fade, let it fade the way galaxies do, not into silence, but into seeding. Let the ideas, the kindness, the curiosity you've released continue their long journey outward until they find new eyes, new hearts, new worlds. Because in the end, nothing luminous is ever lost. It only changes form. The universe expands, the stars cool, the distances grow. But somewhere, across all that space, a small consciousness looks up and remembers. That consciousness is you. That memory is us. And that, my friends, is how the universe keeps its fire alive.